Hello and welcome to the University of Cincinnati Analytics Summit. My name is Alex Gutman and my presentation is titled When a Data Geek Speaks. The intended audience for this presentation is not data scientists, though I imagine there are a lot of data scientists out there and I do hope you enjoy this talk. But this is really for people on the periphery of data science. It's for the managers, executives, business professionals, engineers, computer scientists, pretty much whoever works with data geeks, people who work with people like me. And I say the term data geek as a term of endearment because I am one. I'm a data scientist at 8451. We're the data and analytics arm of Kroger, located in downtown Cincinnati. And my intention with this talk is to pull back the curtain a little bit for people on the periphery of this field to let them know about what your data scientists what are some of the challenges that they face at work? And I also want to address this communication barrier that I feel like exists between the data side and the business side. Um, and a lot of it starts with the way we first learn about data science or machine learning, big data, whatever, and that's through these headlines and or other various technologies. Now this slide is busy on purpose just because it's going through probably if you had to describe this field to a complete noob where you'd talk about self-driving cars or Watson, maybe Moneyball. You might mention Elon Musk and the AI apocalypse. We're just bombarded with this headline view of what data science, AI, or analytics is like. And then you add in quotes like this from Mark Cuban or other tech billionaires saying, if you're not doing deep learning and AI, you better learn it, otherwise you're going to be a dinosaur in 3 years. And he said this 3 years ago. And I've always imagined this thought bubble over people's heads as they're reading these news articles or sitting in a conference where somebody is talking about this, where they're thinking, okay, I don't really understand what's going on, but it certainly sounds like data plus science equals a bag of money. And there are no shortage of companies out there who'd be happy to work with you to get some of that money. This is the data and AI landscape of 2019. And I know you can't read all the vendors on this slide, and that's kind of the point. But I share this not to say anything bad about the vendors. They employ a lot of really, really smart data scientists, and I use and really like some of these tools. But I do take issue with the way that some of this is marketed because it's almost like an infomercial where if you go to a conference or you see one of their pitches, they're painting your business as your life is in black and white. You can't figure out the simplest things. You're spending money that you shouldn't be spending. And then only if you bought this thing, the shiny new machine learning tool, then your life is great. It's in color, you're making money, and it happened instantly. You're going to be the next Tesla or Google or Facebook. Well, this doesn't really happen. So that brings us to the so what. And most of what people learn about data science is not from data geeks. It's viewed through this marketing lens. And the reality is that data science on the front lines, it does not match the marketing. The data science, machine learning, whatever you want to call it, it's about numbers and nuance and uncertainty, and it's rarely simple. But yet there's this entire industry out there that would lead you to believe otherwise. And this creates a disconnect and this communication barrier between the business side who expect these great things now that the tool has been purchased versus the data scientists who are in the weeds, working on some of the challenges that I'm going to share today. So after the vendors and consultants, they've left town with the money, and they leave the employees of the company in a meeting room to figure this all out. But it often ends up with the scene that plays out like this, where, all right, AI is the future. Let's move faster, and we have all this data. Go find something interesting. And the data scientists may say, okay, what are you trying to do? And then we get into the weeds a little bit and start to play with our favorite tech tools, and maybe we'll build some machine learning models in Python. And then it's like, okay, just give me a number. And we'll spit out numbers, R squared values and P values. And then, well, that's not the answer I was hoping for. Can you try something else? Both sides just get frustrated. They just don't get it. The other side's thinking the same thing. One side thinks, okay, they need to dumb this down, and the other side thinks they need to smarten up. And I present that not to point sides, or sorry, not to point fingers. It's like a caricature of maybe some of the experiences that you've seen before. But I hope that resonated with enough of you just to make the point that this communication barrier is real. And I think both sides, the data geeks and the business partners, we both need to do better to meet in the middle. I'm fully aware that data scientists are not known. We're not known for our communication skills, so we have work to do. But on the business side, I feel like there's work to do as well to learn some of the technology, to understand what really goes on behind the scenes, so that we can start to remove this barrier a little bit. Because within a company, we all share the same goals, but in terms of data and data science, I feel like we're just speaking a different language sometimes. So this is a problem where data science can become about lending false credibility to decisions that we've already made, where people love it if it agrees with them. If the data disagree with that gut feeling, then we'll just dismiss data science. And this is a big deal because it's very easy to dismiss something that we don't understand. And we're seeing this play out right now in society with some of the COVID-19 models that are predicting daily case counts or daily death rates, where the models are wrong, as all models are, and that has led to some people and organizations not just distrusting or dismissing some models, but almost the entirety of the modeling process, which is a mistake. And from a business point of view, if people can't grasp some of the concepts, then all of it's kind of viewed like magic. But if it's viewed as magic, it's hard to look at problems and say, okay, machine learning can help me here, or I need a statistician's help with this problem. And then if expectations don't match reality, then frustration will set in. Both sides will get upset. There could be backlash. And as a data scientist, I certainly don't want that. There could be enough backlash if expectations aren't aligned to where maybe a business or a company just dismisses this whole idea of working with data, which would be it would be very bad, because data science, and machine learning, it can solve so many important problems, but it can't solve every problem, and that's something that all sides need to recognize. All right, so let's switch gears for a little bit and do a quick thought exercise. So imagine you're walking around this area of downtown Cincinnati. This is over the Rhine, and it's surrounded by local independent restaurants in blue, a few chain restaurants in red, and you see a new restaurant being built here with the X, and you're thinking to yourself, okay, I wonder if this is going to be a new independent restaurant, or if it's going to be a chain restaurant. So think about what your prediction would be, and also how much money you would wager on that prediction. And then imagine you're in this area outside of Cincinnati near a shopping mall, the Kenwood shopping mall, where you have a lot of chain restaurants labeled in red or with the fork and knife icon. And you see a restaurant being built here, and you're asked to make that same prediction. Is it a chain or is it not a chain? And how much money would you wager? Well, in your head, you just did something called classification, where you made a prediction whether something was one of two classes, whether it was a chain or an independent restaurant. And your thought process, you may not have realized it, but you probably did an actual machine learning algorithm called K nearest neighbor, where if K is 9, you would look at the 9 nearest neighboring restaurants to that specific point and take a majority vote. If 6 out of the 9 were independent, you would guess independent. And I asked you to wager money just so you would go through the exercise of recognizing that there's always room for uncertainty. All models are wrong, some are useful. That's a famous quote by a statistician named George Box. All right, so what was the point of that exercise? Well, if you're not a data scientist, you may not have ever thought about this concept of supervised learning, or maybe you read the definition, but in my opinion, it helps to kind of go through a thought exercise as opposed to just reading the definition that I have here. So what you did in your head is you took information as inputs, the location of a restaurant, and you took known outputs, sometimes called the target, and you use this this label here to train your mind, to kind of supervise your mind into forming a relationship between the inputs and the outputs. And this is what supervised learning is about. And you use that information, you build a model in your head that you can use to take the location of a new restaurant and make a prediction. So keep that example in your head for the next few slides, because I want to talk about some of the challenges that data scientists face behind the scenes when working on problems like that. So again, that supervised problem was very easy, but I hope it showed you that it requires a few things. It requires certain ingredients to do supervised learning. And once you have this idea that you can use labeled data to build a model, then you can understand other supervised learning applications. Self-driving cars are supervised learning application. Whenever you say, Alexa, play a song, it's supervised learning. And behind the scenes of all of these applications are certain commonalities. And it's this, and it's all about the data. It's about having relevant data, accurate data, and enough data. And if you've ever wondered in your business, like, oh, can we predict whether a customer will X? The next question you should ask is, okay, do I have the right data or the right ingredients to even make a prediction model? In my experience, that question is asked, and then I'll ask, okay, have we ever collected data on that in the past? And the answer is no. And then my response is, well, we don't have a machine learning problem yet. We have a data acquisition problem, because it needs to be about collecting relevant, accurate, and enough data. If you were given only this information, where you had the location and whether or not it was a chain, and I asked, could you predict if the restaurant was kid-friendly or not? The answer would be no. A computer would certainly not be able to do it, because it only knows these 4 columns of information. So the data needs to be relevant to the question being asked of it. It needs to be accurate. How many times have we opened up a data set and I highlighted parts that are mislabeled or missing? And you need to have enough data. If you only have a handful of examples, you really can't train a good model. So good data is essential. If you don't have data, you cannot do supervised learning. And for the data scientists on the phone, or some of you who have worked with this day to day, this seems so obvious it's almost not worth stating. But this, in my opinion, we do need to say it more often, because so many times we're asked questions as data scientists where just because there's a ton of data sitting somewhere, a question is asked and then like, okay, we have the right data. But often we don't. Like, the data for a specific problem needs to be relevant, accurate, and enough. So good data is essential, and it's true of all supervised learning problems. So let's take self-driving cars, for example. Once you've conceptualized this idea of supervised learning, how you have existing, where you're building patterns based on a training data set, then it kind of takes some of the magic out of it. So some people are surprised to learn that behind the scenes of self-driving cars, you have images like this that people went and labeled. They were paid a nickel or a dime to say, this is the road, this is the sky, this is a car. Or it's done free by all of us whenever we go buy tickets on Ticketmaster, where we're asked, okay, select the stop signs or select all the street signs or all the motorcycles. Some of them are getting pretty hard now. But this data is actually used to build self-driving cars. And I bring this up because there's such a huge investment in data acquisition, collecting the relevant data, enough data and accurate data to power the machine learning and AI things that we see about on the headlines. But most of what we hear about is just the sexy aspect, like, oh, they did deep learning and they have all these supercomputers. Less is heard about this data acquisition strategy, which could take years and years. And in my opinion, this is what companies really need to start to focus on: is better data acquisition, and not to be enamored with the technology or the latest and greatest, like deep learning. Not to say deep learning is not great, it is, but it's mostly about the data. So, companies might think they have all the all the data that they have is sufficient and they just need the right algorithm to unlock it. But it doesn't work that way. So as an analogy, you have ingredients to prepare a meal, and then you have your instructions, how to put all the ingredients together, and you end up with a meal. So on the machine learning side, you have data, and then you have an algorithm that you use to figure out the patterns in the data, and then you end up with a predictive model. But a lot of what companies are focusing on now is this middle part, where we don't even worry if you have dog food over here. You just like, well, let's try deep learning, and maybe that's gonna work. But that would be like giving a 5-star chef rotten ingredients. So this is the old garbage in and garbage out term that many of us have heard in the past. So we really need to start thinking about better data acquisition to answer problems. So another challenge that data scientists face is expectations on progress. Unlike some projects that might follow a nice linear trend where every 2 weeks you can kind of check a box or mark a cell green on Excel, data projects can often fail in unexpected ways. So this is an example from the data science competition website Kaggle, where there was a baseline model that was 35% accurate. And the goal is to get to 70%. So after less than a week, data scientists have just made huge improvements, getting up to 68%. So like, all right, this is going to be done probably over the weekend. But weeks and months went by and all the work plateaued. So now it's in July. So this is a reality of working with data. There comes a point where you squeeze all the information out of a data set. You've reached the limit of the algorithms, but this is not known in advance. And this is despite, in this case, this is the y-axis is the number of teams working on this problem. So thousands of teams are working on this problem, but progress stalled. So imagine the conversation with management saying, oh, you remember that project we thought we were going to be done with a month ago? Well, it stalled, and we really don't know what to do yet. So at that point, it goes back to, can we collect additional data? What do we need to do? So the data challenges and the expectations of progress are really just two of the issues your data scientists are facing. Another, as I mentioned at the start, is this communication barrier. And there was a survey done by Kaggle, that same data science competition website, where just asking everyone's pain points, and many of them revolved around breakdowns in communication. Lack of a clear question to answer is so important, or it's important to have a clear question to answer. Results not used by decision makers, explaining data science, expectations of impact, there's that expectations again, lack of management support. So in this slide, I took this slide from Simply Statistics, where it's talking about how important communication is. Because when problems are thrown over a wall, if iteration is not happening, then this is what happens. So I'll take a minute to explain this graph. We often think we start with a very, very high quality question. And sometimes it is, I'm saying thrown over a wall, but data scientists are asked to do something, and then if there's not enough iteration, we just take the question as is, and then hopefully we can just apply all that cool technology that we learned about in school to give it strength of evidence, and we reach our goal. But in reality, we often start with a kind of a vague question, and if we apply all that technology, we end up with a very, very precise solution to the wrong question. So the real job of a data scientist and you, the business partner, is one of iteration, where you need to work together to go through this meandering path where you get some evidence, you realize, okay, we need to refine the question, you get some more evidence, you realize you refine the question, and then eventually you get to a much better question, and then hopefully at that point you can apply the technology and get much closer to your goal. And another communication challenge stems from a data challenge with this idea that with data we can measure everything, which is just false. So imagine you were asked, how can we use our stored data to drive loyalty? So how do you measure loyalty? Given our time constraints, you don't really have time to think about that, but computers need very, very specific and sharp definitions. There is no wiggle room with a computer. If we were doing this live and there were 50 people in the room, and I might ask for some volunteers to count how many blue shirts are in the room or how many people are tall, and we would get different answers depending on different criteria. And the reality is counting can be quite hard. We're seeing this now, and if you look at the news, arguments over the COVID death totals and how CDC and whether or not something's labeled as a COVID death or not. So the point being is that data and getting the measurement right is hard, and this takes a lot of iteration between data scientists and business partners in order to come up with this very, very specific and sharp definition. And at the conclusion of a data science project, there are a couple measures of success. These first three is nothing new knowledge is created, you have a cool presentation or an app, policy is made. But number 4 is one that I like to bring up, where it's learned that the data that you have cannot answer the question being asked of it. This admittedly is a little controversial because it doesn't seem like anyone's going to earn their bonus by telling the boss, like, well, we couldn't answer that question, everything was a success. But this really is important to be viewed as a success, because if it's not, then we might force solutions where one doesn't exist. If we get to this point quickly, realizing that the data cannot answer the question being asked of it, then it's possible to talk more about data acquisition, collecting better data, collecting the right data, or at least refining the question so you can get closer to the overall business goal. So we're reaching towards the end of time. I know I've gone over 20 minutes. And so I just want to leave you with a few things to think about the next time a data geek speaks. You do want to make sure that a clear question has been asked. That was one of the concerns on that survey. But be aware of the challenges that they face. Don't be enamored with the technology, the algorithms, but you do want to be aware of the data challenges, because you may need to pivot on the business side to think about how you collect better data. And you always want to be aware about the uncertainties in models. This alone should be its own talk. There's uncertainty and variation in everything that we do. And you also want to make sure that expectations are aligned with what's really possible with data science versus maybe the way that that the marketing presents it. And it is important to recognize that good work can end with, well, we can't answer your question. And then hopefully this goes back to more data acquisition. So I have a few references here. Now, I wish we had more time together. Normally I give a version of this talk in 2 hours, so it was really condensed. I hope you're able to pick up a few interesting things and I hope this makes working with your data scientists a little easier in the future. So thank you.